Hello, welcome. Today's lesson is on tips to memorize ions. But remember, you get a 3x5 card on a quiz or test, so if you can't memorize all of them, put them on your cards. So this list will be on Blackboard, and let's go ahead and just look at it. So this list has common ions that we're going to be using on quizzes and tests. And we have our positive ions here. These are +1, +2, +3, and +4. And these are -1, -2, and -3. But that's a lot to memorize. But it's not that hard because there are a lot of hints and mostly from the periodic table. One silly thing I like to remember is that cations, that's the name of positive ions, that cations are positive. Oh, I love that. Cats are positive. And how can you memorize these a little bit easier using the periodic table? Well, you should remember from our periodic table activity that alkali metals, the first column, like to lose one electron and become +1. The alkaline earth metals lose 2 electrons and become +2, and the aluminum family loses 3 electrons and becomes +3. So here all of these ions, hydrogen, lithium, sodium, all of these like to become +1. These become +2. We skip the transition. These become +3. So when we look at the ones you have to memorize, you already know the names of the alkali metals. Hydrogen also becomes +1, and the alkali metals, lithium and potassium and sodium, they become +1. And the alkaline earth metals, barium and calcium and magnesium and strontium all become +2. And then we have a few more which we'll talk about. Those are the transition metals. Transition metals can have more than one charge. And to distinguish between them, we give them a Roman numeral. So copper can become copper-1 or copper-2, like it says there, but if I get too close, it blocks it off. So copper can become copper-1 or copper-2. So the transition metals, the ones here, can have multiple charges. And so we give them a number. So copper can become +1 or +2. So to tell which ion it is, we put copper with a Roman numeral 1 to mean copper with a +1 charge, and copper with a Roman numeral +2, or Roman numeral 2 is a +2 charge. There are some exceptions to the Roman numeral for the transition metals. And there we have zinc here, only goes to +2. It doesn't go to any other ion, and silver just does +1. And I like to remember on the periodic table this diagonal right here, aluminum is +3, zinc is +2, and silver is +1. So here, this column is +1, this column is +2, aluminum is +3, +2, +1. The rest of them get a Roman numeral to tell us what charge they are. So if I asked you what's the charge on Fe Roman numeral 2, the charge is +2. And so here we have a lot of these iron +2 and copper +2 and cobalt 2 and nickel 2 and tin 2. Those are all transition metals here. Tin and lead, that's a representative metal, but it also gets a Roman numeral. So there you have it, easy ways to remember the cations, or if you can't remember them, put them on your 3x5 card, but you might want to save the 3x5 card for other things, so you might want to at least memorize some of these. What about the anions? Anions, a way to remember that is A for A, and for negative, they are A negative ions, so anions are negative. And elements that become anions change their name ending to IDE. Remember, we've just named covalent compounds, and they also named the second element with IDE, so this is still the same. So chlorine, instead of chlorine, when it becomes a negative ion, an anion, we call it chloride. So from the periodic table, we can get a lot of information also. So here, this side of the table becomes negative. So this family, the nitrogen family, becomes -3, at least especially these two that we're going to talk about, the nitrogen and the phosphorus, but they become nitride and phosphide. This column likes to gain 2 electrons, so it becomes oxide and sulfide. And notice we're only going to be using the nonmetals here for the anions. And then fluorine, chlorine, bromine, and iodine become fluoride, chloride, bromide, and iodide, and they become -1. And the noble gases don't usually bond or take charges. So let's look at the ones we have to memorize. So here we have chloride, bromide, fluoride, and iodide. All of those you could get off the periodic table. Down at the -2 charge, we have oxygen as oxide and sulfide as sulfur 2-, sulfide is S2-, and then nitride and phosphide are 3-. But you may notice on this side of the table, we have many of them that look different. They have multiple atoms together. We only had one here on the cation side, but look at these. I have several that are not just elements on the periodic table. They are more than one element on the periodic table. And those are called polyatomic ions. Poly meaning many, atoms. So they're made of more than one atom and they're bonded together. So nitrate was one of the ones we had on the chart. And nitrate is 1 nitrogen bonded with 3 oxygens. So remember from the covalent naming, this subscript here means there's 3 oxygens bonded to a nitrogen. And this superscript means the charge. It has a -1 charge. So be careful, don't think this has a 3- charge. The 3 tells me how many oxygens, that's a subscript. We put the charges, remember when we were talking about isotope notation, the charges go in the top right. All right, so it's a superscript. So this is nitrate, 1 nitrogen and 3 oxygens covalently bonded together. So if a group of atoms that are covalently bonded, like this nitrogen and 3 oxygen, they bond together and this one gains 1 electron. So this whole thing is 1 ion and it has a -1 charge. And now, even though nitrogen and oxygen are covalently bonded, this acts as an ion and it will participate in ionic bonding. So this is like one group and it is an ion. And there's a lot of similarities to help you remember these. The 8 ending indicates that it has oxygen in it. So phosphate has a phosphorus with 4 oxygens, sulfate has sulfur with 4 oxygens, nitrate has a nitrogen with 3 oxygens. So how am I going to remember those? Well, if it has an 8 in it, you know it's going to contain oxygen. And it's lucky that phosphate has the same charge as phosphide. Sulfate, which is -3. Sulfate has the same charge as sulfide, so that might help me memorize that also. But unfortunately, there is an exception to that rule. Nitrate does not have a -3 charge like nitride. It has just a -1 charge. So maybe you want to put that down on your 3x5 card. There was one polyatomic ion, and it's a pretty common one, so you want to know this. This is the ammonium ion, and it has 1 nitrogen bonded to 4 hydrogens, and it loses an electron, so this whole unit becomes +1. So there you have it. Use your periodic table, +1s, +2s, +3, +2, +1, -3, -2, -1. And then we also have polyatomic things like phosphate, which is -3, and sulfate, which is -2, and nitrate, which is -1. So there you have some ways to memorize. If you're not good at doing that, then make sure you have room on your 3x5 cards to put them. So there you have it. Thanks for listening.